Day 2 of 10.1 is all about real-world applications. So for each word problem, you're going to have to read and identify what's important, draw a picture, write an equation, and solve. And then you also need to make sure that you write your final answer with units. So I'm even going to write these step downs for you. The first thing you're going to do is read. And I'm going to put underline because that's what I do to my important information. The second thing you're going to do is draw a picture. From that picture, you're going to write an equation. Step 4 will be to solve that equation. And step 5 is write your final answer with units. So each word problem is different, but the process is sort of the same. So I'm just going to jump right in and try part A with you. As I go, I'm going to underline what I believe to be important. A builder is constructing a wheelchair ramp from the ground to a deck with a height of 18 inches. The angle between the ground and the ramp must be 4.8 degrees. So I know it's cut off a little bit, but I underlined the angle between the ground and the ramp must be 4.8 degrees. To the nearest inch, so it's telling me how I'm going to round my answer, what should the distance, D, between the end of the ramp and the deck be? So, I underlined what was important. I even put a squiggle with what I'm trying to find, the distance between the end of the ramp and the deck. And now I need to draw a picture. So a builder's constructing a wheelchair ramp. So a wheelchair ramp would look something like that, right? It starts at the ground, it goes up, and here's the deck right here. So I know that the deck has a height of 18 inches. So this is the height of the deck. It's 18 inches. Here's my ramp here. I know that the angle between the ground and the ramp must be 4.8 degrees. So if here's my ground and here's my ramp, this is the angle that's created by those two things. So this angle must be 4.8 degrees. And then what am I trying to find? I'm trying to find the distance between the end of the ramp and the deck. Okay? So here's the distance between the end of the ramp right here and then the deck, which is over here. Usually when I say distance, I mean the horizontal distance. If I would have wanted to know what the length of the ramp itself is, I would have said, what is the length of the ramp? But I want the horizontal distance here. So this length right here. If it helps, draw a cleaner picture of what's going on. I have a right triangle. I know that this is 4.8. I'm solving for D, and this is 18. Or I have theta, an opposite length, and I'm trying to find an adjacent length. Well, which trig function uses opposite and adjacent? If it helps, write so, ka, toa, and we're just going to stick to our basic 3 for now. We could use cosecant, secant, cotangent, just to make it easier on ourselves. I'm not going to. So tangent uses opposite and adjacent, so I need to write tangent of theta, which is 4.8, equals opposite over adjacent. So now I need to solve for D. We need to get D by itself, and I typically see some mistakes here when I have students solving. If I'm solving for D, it cannot be in a denominator. It must be in the numerator. So I'm going to have to multiply each side by d first to get it back in the numerator's position. So I have d tangent of 4.8 equals 18. Now I'm multiplying tangent of 4.8 times the variable d. So to get rid of it, or to get d by itself, you'll have to do the opposite, which is to divide by tangent 4.8. Now, if you have a TI 30x, you have sine, cosine, tangent buttons. If you have a different calculator, you might want to look where it says Trig. I'm sure you can find videos online on how to find it. If you have issues with your calculator, just let me know. But I'm going to plug it in exactly as I see it. It's 18 divided by tangent of 4.8. And then I'm going to close that parenthesis there, showing I'm just taking the tangent of 4.8. So d is approximately, because I'm going to have to round to the nearest inch, 214 inches. Notice how I put my units on my final answer. Okay. Before I do part B, I need to talk about angles of depression and angles of elevation. So when you have an object that is above or below another object, we can find the distances using angles of elevation, which is the angle from the object looking up, or the angle of depression, which is from the object looking down. So when I say object looking down, I don't mean in my right triangle, I'm not talking about this angle here. That is not the angle of depression. That's in our right triangle. Instead, it is this angle right here. We want to create two parallel lines, and the angle of depression is going to be the alternate interior angle of the angle of elevation. So again, that's the alternate interior angles. And the reason why we're using alternate interior angles is because we know that those are congruent lengths. All right, let's try part B. By the way, you'll know when to use this information because it'll say in the problem angle of depression or angle of elevation. So part B says, I'm going to underline as I go, the pilot of a hot air balloon measures the angle of depression to a landing spot to be 20.5 degrees. If the pilot's altitude is 90 meters, what's the horizontal distance between the balloon and the landing spot? So this is what I'm trying to find. And I want to round to the nearest meter. So I've underlined what's important. Now I'm going to draw a picture. Okay? So we're going to be using right triangles for all of these. So here's my right triangle. I have a hot air balloon, so I'm assuming that's in the air, right? Here's my hot air balloon. Now, its angle of depression to the landing spot, which will be right here, is 20.5 degrees. That does not mean that this angle is 20.5. This is not the angle of depression. The angle of depression we get from drawing a parallel line to the ground. So this right here is my angle of depression, which is 20.5 degrees. And this angle just so happens to be congruent to this angle by alternate interior angles of parallel lines. So this is 20.5 degrees as well. And I wanted to find the horizontal distance between the balloon and the landing spot. So this is the horizontal distance, this is vertical. And I also was given that the pilot, who's right here, his altitude is 90 meters. So altitude, think of it, altitude is the distance between the ground and an object in the air. So the vertical length would be 90 meters. If it helps, you can redraw it so it's not so crowded. I have a right angle. My reference angle will be right here. It's 20.5 degrees. This is 90, and I'm trying to find the horizontal distance. So sometimes I like to include everything just so I have a clear picture of what's going on, and then I clean it up to make it easier for me to see what I'm actually solving for. So this is my theta, or my reference angle. 90 is opposite, and then distance is adjacent. So it just so happens both of these are tangent problems, but sometimes I will give you a sine or cosine, and you're going to see that in your homework. So I drew my picture, time to write the equation. Tangent of 20.5 equals opposite over adjacent. Now I'm going to solve, multiply each side by d. That gives me d tangent of 20.5. Remember, we're multiplying these things together. So to undo, I'm going to have to divide. D equals 90 divided by tangent of 20.5. Remember, it said rounded to the nearest meter right there. So approximately 241, because that 0.7 would boost this 0 to a 1. And then my units was meters. 241 meters. Once again, I just want to remind you that the general process is read and underline, draw a picture, write an equation, solve, and then write your final answer with units. When you solve, you could use sine, cosine, or tangent dependent upon your picture. It just so happened both of my examples were tangent problems. Okay, you will see sine and cosine on your homework. And another reminder, the angle of depression we get by drawing a parallel line to the ground. And the angle of depression is congruent to the angle of elevation because they are alternate interior angles.